So inequalities come to this. First, you need to recognize when a graph is a line or when it's a parabola. But it essentially comes down to this when they're first teaching you. In a in a Cartesian graph, x goes up this way and y goes up this way. So when we're asking when is y bigger than, let's say, a line, if this was the line here, y is bigger than this red line on this side. But when it says just bigger, it just means if it said equals, it would include the line. But when it says bigger, it means it does not include the line. So we would say something like this. So visually, y is bigger than this red line everywhere up here because y gets bigger as we go up the Cartesian graph. If we were to look at what's smaller in here, of course, it's on the other side of the graph. So if we say when is y smaller than this line, it's everything on here, down here. And again, it does not include the line because it says smaller than. So we'd have to dot our line. When it includes the line, when it says smaller or equal, we would say that. So when it's smaller and equal to whatever the line formula is, like 2x plus 3, it would be this. The second thing is when to recognize when a graph is a line or a parabola. So when you see something like this, this is the basic slope intercept formula for line. It's called that because this is the slope. Sorry, and here's the, let's say a 3 is there. And that would be the y-intercept. So like, for instance, when is the y-intercept? It's when x is 0. So 2 times 0. We end up with 3. Y is 3 when x is 0. It's called the slope intercept because if you get rid of this, you instantly find out what the y-intercept is. It's called the slope part because that's the slope. But you would need to know how to draw this. And how you draw this is you have a normal Cartesian graph. And you say, okay, what is y when x is 0? Well, 2 times 0 plus 3. When x is 0, which is here, y is 3. So we put a dot there. What about x? What about when x-intercept? Well, that's when y is 0. And we would solve it. We subtract 3 from both sides. Minus 3 is equal to 2. Let's make it plus 4 instead. Okay. So the y-intercept 0, comma 4. And then when we solve it, we say minus 4 is equal to 2x. Divide by 2. X is equal to minus 2 when y is 0. So we would put that here. Probably closer here. Minus 2, comma 0. Now that I have 2 dots, I can join it. That's not a good join, but you get the idea, and that's my line. That line will have a slope of 2. In other words, it goes up. It goes up 2 for every 1 it goes over. So it's important to understand the line formulas. That's the slope intercept. Sometimes you'll see line formulas like this. Equals to a number. And this is actually a handy thing because we can discover when y is 0, this disappears. X is, divided by 2, x is 6. When x is 0, y is 4. So we'd have 6, comma 0 and 0, comma 4. That's our 2 intercepts. And this way of writing a line gives us a quick way of figuring out the intercepts. And I forget what style this is called, but we're used to always having y equal something, the slope intercept formula. Now that's just when is something above a line. But sometimes when you're looking at a Cartesian graph, they'll give you a line. Let's just get rid of that. They'll give you one line like that. And as long as lines aren't parallel, they will always cross. And they'll say the blue line. And the question will be, when is the blue line above the red line? And it's clear it's at this point here afterwards that the blue line is above the red line. And that would be, when is this formula bigger than this formula? Okay. When is it smaller? When is the blue line smaller than the red line? Well, it's on this side. So it'll be everything to the left of this x point. And we use the x value to denote when this happens. Let's say this is at 4, 3. We'd say the blue line is bigger than the red line when x is bigger than 4. In other words, to the right of this x value. And we would say the blue line is smaller than the red line when x is smaller than 4. To say everything on this side where the blue line is below the red. To do this, when you have two line formulas or two parabolas, let's say that's the line formula for one of them, y is equal to 2x plus 3. And the other one is, I don't know, 4x plus 3. Let's say this is the red formula, the red line. You can simply get it all to the same side. Oh, let's say 4, because that's, or 6, yeah. 8, no, 6, because that's not going to work. You simply get all the x values to one side. And all the 2x minus 2x. And all the numbers to the other side. When is it smaller than minus 3? Let's go with instead 3, smaller than positive 3. Let's instead go with 7. There we go. When it's smaller than 4. When x, and now here's a weird thing. So to get this x alone, I have to divide by minus 2. When you divide by a minus number, the sign switches. So when x is bigger than minus 2 is what they're telling me is the answer. When is the blue line smaller than this red line? When x is bigger than 2. When I divide by minus 2 here, this sign has to switch directions. Let's see if that's true. The simple way of figuring out if that's true is to put Desmos and say, okay, well, here's my first line, 2x plus 3, 4x plus 7. When is the blue line bigger than the red line? Apparently when we go past minus 2 on the x value. So let's have a look. There's minus 2x right there. We can see it right there. And sure enough, the blue line is above the red line from that x value on. The y value doesn't matter. To figure out where they meet, lines meet when they share the same y value. Lines meet when they share the same y value. Since this line is y is equal to this, and this line is y is equal to that, well, they will share the same y's when they meet. So this 2x will be equal to the same y value as this formula. So instead of doing that, you say, well, when does this formula equal that formula? And you solve it again. So you get minus 2x, and we get the same answer. Minus 2x is equal to 4. X is equal to minus 2. We discover it meets x minus 2, and you just plug that back into either formula. So minus 2 here is minus 4 plus 3 minus 1. We discover it meets at minus 2, so you find that x value the same way we did before, and you plug it into the formula, and you get, let's see if that works. Yeah, minus or plus 1. Was that correct? Minus 1. Yeah, minus 1. So it tells me that these lines meet at minus 2, minus 1. And sure enough, when you look at the graph, they do indeed meet there. This is true for parabolas too. You do the same methodology for parabolas. Okay, so now let's go back to the item. Let's see if I still have it. So let's look at the situation. In this case, they just want to know where the ordered pairs are. So we would instead say, okay, since we're asking when is this line, it's very confusing because of how they've written the line. We would do it like this way. So they've just asked us which one of these are possible solutions to this equation. Well, this is quite easy because all you would have to do is you would have to plug in both values into the formula to see if it's smaller than 18. So 3 minus 3 times minus 5 is plus 15. So 18 is on the left. Is 18 smaller than 18? No. That's because that point is right on the line. So that is not below 18. 0, 0. So you get 0 minus 0, which is 0. Is 0 smaller than 18? Yes. So that's below. This is the true solution. Well, with minus 5 and 3, well, you get minus 5 and positive 3, which is minus 9. So you get minus 14, is minus 14 smaller than 18? Yes, that is below. What about 5? You get 5 minus minus becomes plus 15. Plus 10, is plus 10 smaller than 18? Yes. 5 plus 15, 20. Is 20 smaller than 18? No. So that's not on the line. You do the same thing here. You plug in the 5 here. You get 10. 2 here. 10 minus 10, 0. Is 0 smaller than 0? No, it's right on the line. 2 comma 5. 2 in here. 4 minus 10 is, so is 0 smaller than minus 6? No, 0 is not smaller than minus 6, so no. Minus 5 in here, you get minus 10. 2 in here, you get minus 10, so minus 20. Is 0 smaller than minus 20? No, it's not. And finally, 2 in for here, I'm sure this is going to be a good answer. You get 4 minus 5 in here, you get minus 5, which is plus 25. So 29, is 0 smaller than positive 29? Yes. So this is the only one that has a solution where this becomes true. Graph. Okay, so this is asking you to visually figure it out. So the secret again here is to be able to learn how to graph a straight line. So this is in the intercept slope format. So this is always going to be the y-intercept. So we can put it there, 0, y, 0, 7. But we need another line to get an idea. So we have to say, give me any other point. Well, that's when y is 0. So we're going to solve this. When is y equal to minus 2x plus 7? We get the 7 to the other side. Minus 7 is equal to minus 2x. Divide by minus 2, you get x is equal to 3.5. So that means that 3.5 for x, y is 0, which is right there. Now that I have 2 points, I can draw a straight line between them. And that's my line. And if the question is asking when is y below or equal to this line, now we can just sort of draw it in. That's below the line. Those y values are all below the line. And we keep this a solid line because it says equals. This is written funny, isn't it? But it allows us to find 2 points easily when y or x is 0. When x is 0, y is minus 9. So way down here. When y is 0, we get 3x is equal to minus 9. You just treat it like an equal when you're solving these. And so x is minus 3, so that means it's over here, minus 3, 0. Now we can just draw these lines. Join these points with a straight line. Something like that. And the question is asking now, if we go back, when is this below minus 9? Well, no, we need to solve this in terms of y now. So we're going to get the 3x on the other side. And we're going to keep the y here. I'm going to make it a little less crazy big. So we're going to solve for y. We have to get that 3x to the other side, smaller than minus 9 minus 3x. Now we're going to reorder it in terms of x first. There we go. So it's essentially asking me when is y lower than the line. And this is the line, even though I've rewritten it in a different way in the slope intercept format. You can see it gave us the proper intercept again, minus 9. But essentially asking when is y below this line, which again is here. But this time it doesn't say below or equals. So we do a nicer sketch of drawing underneath. It doesn't say smaller or equals, it says smaller. So we do not include the line. It's the same methodology for a parabola. And for 2 parabolas, you have to solve. So we'll keep going. And they're just explaining how to draw it. The same thing, you would figure out where this line has 2 points. And then figure out when is, and notice it's written as x. Well, we don't really do it as x. Maybe your teacher has a way of doing it with x, but you don't really ever do it in terms of x. You always do it in terms of y. So you'd have to rewrite the line, and that's what he's trying to teach you. It's making it a little convoluted, which is too bad. But whatever. Let's find out when 2 points. So when y is 0, just ignore the smaller, just pretend it's x is equal to 2y plus 0 plus 8. When y is 0, we get the x-intercept. So x is 8. So we draw the point 8, 0 right there. And you'd label it. You should put 8, 0 there, but we're not going to. And then when x is 0, We put an x and 0 over here, and we solve. So we bring the 8 over when minus 8 is equal to 2y. We divide by 2 when y is equal to minus 4. So we get the next point right here. Then we just join the line. Like this. It's not really well joined, so there we go, a little bit closer. There we go, and a little bit off still. So something like that. So we don't know if they want us below or above the line, so we have to readjust for the y. So we have x. I'm going to bring the 8 over. 8 is smaller than 2y. We're going to rewrite it in a way where y is on the left now. 2y, notice that the mouth was open to the 2y, so if I put it on this side, I have to see how the mouth is open to the y side. So I have to make sure the mouth is open to that side. Now I don't want this 2 here, so I divide everything by 2, or multiply by the reciprocal. So it's a half y minus 4. You can see it gave us the y-intercept again in slope-intercept format. But now it's asking us, when is y bigger than this line? That's what they want us to know. So when is y bigger than the line? It's up here. So there you go. So you have to rewrite it to figure out what they're asking. And with anything where the y is not on one side. But to figure out the 2 points, don't rewrite it yet. So when y is 0, divide both sides by 4, x is 5. When x is 0, minus 5y is equal to 20. We divide by minus 4, we get minus 5 rather. Divide by minus 5, we get minus 4. There. And we join the lines. But to figure out if they want us above or below the line, I'm just going to copy this so we have it. We got to go back to the original line without scribbles on it. We got to keep our line that we drew. And we have to say, okay, we got to get y all alone. So we're going to subtract. We get minus 5y is bigger or equal, doesn't change sides, bigger or equal to 20 minus 4x. We're going to put the 4x first, minus 4x first. So it becomes minus 4x plus 20. Well, we got this ugly minus 5 dividing y. So I'm going to divide by minus 5 on the left side, which instantly changes this sign. When I divide this by minus 5, it'll become positive. And plus 4 divided by 5 is 4/5. And 20 divided by minus 5 becomes minus 4. You can see we get the y-intercept automatically here, and this is the slope. But now we can see that the question is asking me, when is y below or equal to this line? By the way, if this was just above, which it was, we had to add the dotted lines to the line. This one's below or equal, well, that's down here. And we leave the line solid because they're saying or equals. Determine the inequality. Well, we have to figure out what that line formula is. So we have to look at it. We have to find some dots on it. Well, we know that this is the formula of any line. Y is equal to the slope times x. And we need to be able to solve it so that we can figure out b and m. Well, b in this case is going to be wherever the y-intercepts here is. So there's b there, and I won't get into what b is over here, but there's b there, 2. So we know this is a 2. We just need to figure out the slope. So now we know the formula is this. Y is equal to mx plus 2. To figure it out, we need any point on this line that's easy to work with. So usually like the intercept down here is easy to work with. Minus 4 comma 0. When x is minus 4, y is 0. We write it like this. When x is minus 4, y is 0. We don't know the slope. but we know that y is, or x rather, is minus 4 when y is 0. So we put in the x value and the y value, but you can use any point. And now we're going to solve for m. So minus 4 times m can just go in front of it. We have to subtract 2 from both sides. Then we just divide by minus 4. So it becomes 2 divided by minus 4. Minus 2 divided by minus 4 is m. And that just becomes positive on the left, and it simplifies to a half. So we have a half. So now we know the formula is y is equal to a half x plus 2. So I've replaced the m with this number that I figured out, and I've left the y, put the y and the x back to normal. Since I can see that this is shaded below the line and includes the line because they haven't put a little dot through the line, the inequality that they're expressing here is y is smaller or equal, because they included the line, a half x plus 2. This one's a lot simpler. All horizontal lines have the same y value. In this case, 1. So it's y is equal to 1. That's a horizontal line. Y is equal to some number. All vertical lines have an x value. So if I put my vertical line here at x is 3, all the x values here are 3 of this line. So we just say x is equal to 3. This is always a vertical line. Y is equal to a number is always a horizontal line. We can see that because it goes through 1 the whole way, the formula for this line is y is equal to 1. We can see it's shaded above the line and includes the line. So we'd say above or equal to 1. This area is above or equal to the y value of 1. That's what they're asking. Even with the other ones. So this one, there's the x or the y-intercept, minus 3. We would just need another clean point. I don't like that point because it's 1.5, but we can use it, but I don't like it, so I'm going to use a cleaner point. So I'm going to start with the y is equal to mx plus b. That's the general formula for slope intercept. I can see from the drawing that it intercepts the y-axis at minus 3. I just need to figure this m, so I'm going to take any x value that I can see that's really easy. And that's not the y-intercept again. Can't use the same point twice. I can see, even though this x-intercept is here, this point here is much easier. It's minus 2 of x and 1 of y. Okay. This point down here is easy too. 1 of x minus 5 of y. So I can use either one. So I'm going to use this one, minus 2x and 1y. So where I see y, put 1. I leave the m because that's what I'm trying to figure out. And the x I can see is minus 2 times the m, and then minus 3. Minus 2 times m, I'm going to rewrite it like this. There we go. So now I just got to solve for m. So I add I add 3 to both sides, I get 4. I divide by minus 2, I get minus 2. So my m is minus 2. So I got to rewrite my line formula as y is equal to minus 2x minus 3. That's the formula of this line. I can see that they have everything underneath the line and not including the line. So the inequality they're expressing here is that the y values below this line, but not equaling the line, just below it, is the inequality they're expressing. Here is x is equal to 5. It's everything to the left of 5, but not including the line. So it's, in this case, all values of x to the left of 5. This is all values below y is equal to 6, or sorry, yeah. Y is smaller than 6. This one's x smaller than 5. This one, we'd have to figure out the x-intercept at 20, y-intercept at 8 to figure it out. There's another way to come up with a line formula. I mean, I don't know if I should teach you. My problem is whether you're going to go into math or not is the problem with whether I should waste time teaching you other methods. But another method is this. Y minus the y value minus any y value, in this case 0 when x is 20 is equal to x minus the 20, like that. That would be at the x-intercept. Let's see if that does it. No, that doesn't solve it. Yeah, that won't do it, because you need the slope in there. So we'll just stick to y is equal to mx plus b. It's a lot faster and easier. I can see my b right away is 8. And I'm going to use the x-intercept when y is 0. It's 20 times m, because 20x plus 8. I do the 8 to the other side. It's minus 8. Divide by 20. So m is equal to minus 8. M is equal to minus 8 over 20, which is the same as minus 2. They're both divided by 4, minus 2 over 5. So there we go. That's the slope. And I can see the line is bigger and equal to this, so everything above or equal to that line. There you go. He's doing a lot of lines. I think he's trying to make you draw lines. So here's a quadratic. You can tell because it's x squared. So lines just have an x. Quadratics have x squared. And they want to know, what are all the points above this? Well, the quickest way of drawing a quadratic is either completing the square to figure out the vertex, or factoring. What number multiplies to minus 8 and adds up to minus 2? Well, that would be minus 4 plus 2. So I can instantly know that these would be the factors. And that instantly tells me the two x-intercepts, 4, 0, and minus 2, 0, which means that when I draw it on a graph paper, we would have 1 point here and 1 point here. Whenever you want to find the axis of symmetry, you go halfway between them. And the easy formula of that is you add the 2 points and divide by 2. So minus 2 plus 4 is 2. Divide by 2 is 1. So the axis of symmetry is here, which tells me the vertex will be here. But I don't really need that. I can tell that this is the line, and this line has a positive leading coefficient in front of x squared, so it's upward facing, which means I know this line looks like this. I don't know where the vertex is, but I do know it's below the x-axis. How do I know that? Because if I have an upward facing parabola and it passes through this point and again through this point, it has to dip down below the x-axis, which means I know this parabola is above the x-axis here and here. In other words, when is the y values above this? Oh yeah, we're asking, when are the y values above this? You might be tempted, well, all the y values are above because there's y positive above it, but you're always looking sort of on the inside of the graph. So we can see all the y values are positive there. And this only, no, is that? No, that's not an accurate description. Sorry. That's not true at all. Which part of this line of the parabola is above 0? In other words, when is it positive? Yeah, sorry, that was right. We can see that the y values technically like that. Anything above this. Now, it's interesting that sometimes they won't ask this, and I should be clear because I kind of paused there. Sometimes they'll say, when is y positive? When is y positive for this graph? And we can see the y is positive here and y is positive here. But it's not positive here. All these y values here, if I took any point here, the y coordinate would be negative. So I just want to cover this because this comes up as well. Y is positive to the left of this x value. So if I was asked, when is y positive? I would say when x is smaller or equal to minus 2. And when is x positive? When x is bigger. Sorry, not equal to, because it's asking when it's positive. When it's smaller than -2, or when x is bigger than 4. When is negative? When it's between -2 and 4. That's when y is negative. But that's not what this is asking. This is asking is when is y above this line? And that's that. Not line, but quadratic. And that's that. But if I was asking when is this bigger than 0, right, it tells me here to the left of -2 and to the positive to the right of 4. And I can tell you this because that comes up more often than these inequalities. Okay, so this is the same thing. When is the y values going to be shaded? This is an upward facing parabola. It's the same formula. This time it's included equal. So it's actually going to be the same thing that we just saw, that I just had before. This was y is bigger than this parabola. Now they're asking when it's smaller or equals. This time they're going to include the line. So you won't see a dotted line. There we go. So that's when you would say, when is it below and equal to the line? Notice the line is not dotted. Notice that when we get rid of the equals, suddenly the parabola line becomes dotted. So these are just sketching things. This is annoying. They give you vertex format. We might as well cover this. Oh, well, I got the whole graph one. No. There we go. Vertex formula. Well, find the vertex. It's the opposite of this -3, so it's 3. And it's exactly what this is, 3, 1. So there's 3x and 1. There we go. Now, is this graph upward facing or downward facing? It's downward facing. Since they just want us to sketch it, technically it would be good to have one other point. And you can always have one other point when x is 0. We get -3 squared, which is 9, gets multiplied by -1, -9, and +1 is -8. So I've drawn this incorrectly. Really go down more sharply, like this. And not quite accurate. I'll squish it. And I'll squish it. Something like that. Not quite. So it would look like that. So this question is asking when is y below. So it's not equal. When it's below and not equal, we have to dot this line. And we can see that y is below inside. Okay, we're asking above. Be this stuff up here. You can punch this into the calculator over here and it'll show you. Yeah, sorry. There we go. This is the same thing I just did. This time they want to know when y is above it and equal. This is a downward facing parabola with vertex -2, 4. This is harder. So to find a parabola, you have to use a generic formula. So the generic formula of any parabola, you could find the vertex and you can use the vertex formula. So there's several ways. Here's the vertex formula. You have an a, an x minus the x value of the vertex. So I can see the vertex here is right. Let's see if I can do it. Did I copy enough? No, I didn't copy enough. There we go. Let's try it again. I think I got enough information that time. We can see the axis of symmetry is right here. And we can see it goes through -4. We can also see it's at 13. So the vertex is -4, 13. So I can just write the vertex formula, missing one bit of information. Y is equal to, there's a number here. X, instead of -4, we have to do the opposite, but then we keep the y value the same. And don't forget that it's squared, because this is a parabola right there. Vertex formula, great. We just need one other point. I think that might have supposed to be 1 comma 0, but it's not clear. But this is definitely 0 comma 5. So we just plug in the 0 for x and the 5 here to solve for a. So we get 5 is equal to a. My x is 0 plus 4, which is 4, squared, which is 16, plus 13. So I get 16a plus 13. I'm going to subtract 13 from both sides. So 5 minus 13 is minus 8 is equal to 16a. Divide by 16, I get a is equal to negative 8 over 16, which is negative a half. So that means I can rewrite the formula with the negative half for a. And this would be the formula. Replacing a with the negative half, which makes sense because this is a downward facing parabola. So it should have a negative number up here. So that means since this is drawn underneath it, but not including it, its y is smaller than this parabola that we've just figured out the formula to. So that's the inequality being shown here. To do it, you need 2 points of the parabola. The other way of doing a parabola, and you might be annoyed by me telling you another way, I'll try to do it faster, is the parabola has this formula. Ax squared plus bx plus c, and these are the things we use in the quadratic formula. Well, to solve it, I just need 2 x values. Let's use first of all, the c is always when x is 0, right? It's the y-intercept. Well, here we can see the y-intercept is 5. So I know that's a 5. Now I just need another point. So I'm going to use any other point that's simple. So let's see, what's a real simple point here? Do I see any simple points? This one's good, minus 2, comma 11, right here. Right here. It's right there. It's minus 2 and 11. So now that I have this formula so far, where I stole the 5 from the y-intercept, I can just start trying with that one. So x is minus 2 when y is 11. So I get that. What's a minus 2 squared? X squared, right? It's positive 4, 4a. And then b, what was my b times x? What was my x? Minus 2. So minus 2b plus 5. So I have a formula that has 2 values. Let's find another point. I can see another clean point. I'm going to use a different one. Right here. Minus 8x and 5y. So we're going to do it again. We get 5. Minus 8 squared is 64a. Minus 8 times x becomes minus, I'm just substituting it all in again, minus 8b plus 5. So we can see that we have 2 different formulas missing 2 equalities. So you can see this is a harder way of solving it. So the secret is to make either one of these b's match or one of these a's match. Well, I can see if I multiply this by 4, it becomes minus 8, right? So, but to do that, I have to multiply everything by 4. Okay, well, let's do that. We get 44 is equal to 16a minus 8b plus 20. So I've multiplied everything on the top by 4 so that my b's match. You can see my b's match now. This is called elimination. To eliminate them, we subtract them. So 44 minus 5 becomes 39. 16 minus 64 becomes very complicated, isn't it? Becomes 16 minus 64 becomes 20 minus 44 minus 48. A minus 8 minus 8b disappears. 20 minus 5 becomes plus 15. So suddenly we have 39 is equal to minus 18 a plus 15. So I can solve for a. I subtract 15 from both sides. 24 is equal to minus 18a. And then divide by minus 18. I get a simplified negative 24 over 18. Both are divided by 6. I get 4 over 3. Negative 4 over 3. So that's my a. Now that I know my a, I can just plug it into any of the simpler formulas. I'm going to say that the first formula I had was much simpler. So again, my a is minus 4 over 3. Let's capture it. Go back to the simpler formula before I changed it, that one. And I would just substitute this a in, and I would be able to solve for b. Once you have the b, you'd go back and put them in for a and b here. Leave the 5 alone. Annoying, but solvable. But you need to do a lot more work than the vertex. So I would say when they give it to you in this format and you need the vertex, complete the square. Here's interesting. They want to know when is this is what I was talking about. When is this below 0? Well, for that, you just need the x-intercepts. So first they ask when it's above 0, and then they ask when is it below 0. So they say factored, find the x-intercepts. This is a more common question. So what multiplies out to minus 12 and adds up to minus 1? It's minus 4 and 3, positive 3. Which means my values are x minus 4, x plus 3. Which means my x-intercepts are minus 3, 0, and 4, 0. Which are here and here. Remember, your x-intercepts are opposite of your factors. And since this has a positive leading coefficient, it's facing upwards. So it's like that. So this is much easier because they're just saying, when is this line above 0? Well, that's when it crosses the x-intercept. Everything above here, the y values are 0. That's what they're saying. Everything below here, the y values are below 0. That's what they're saying here. Well, I can see when we go to the left of minus 3 here, we're above 0. And when I go to the right of plus 4 here, we're above 0. So we would write it like this. When x is smaller than minus 3, or when x is bigger than 4, because it asks for bigger than 0, not included. Another way of writing that is like this. You would write it as I think it's written as a rounded bracket, infinity, negative infinity is on the left, to minus 3, or rounded bracket, because we're not including the 4, and you never include infinity, so it's a rounded bracket. And what this is saying is from negative infinity, which is way on the left, all the way to minus 3. And this is saying from 4 all the way to positive infinity. The graph is above the x-axis. That's what above 0 means. Above the x-axis, above where y is positive. When is it below? Below is a little bit different. Here it's below, right? From there to there. So we would say it like this. When minus 3 is smaller than x and smaller than 4. In other words, x is between minus 3 and 4. We would write that in notation, interval notation is this. Minus 3 rounded bracket, comma, positive 4 rounded bracket, which means between those two numbers. This means between these two numbers, and this means between these two numbers. This is a much easier one because we can see that the two numbers are essentially joined. The reason this is more confusing is because it's way on the left here or way on the right, whereas these are connected. So when is it below? Here. When is it above? Here. That's the same thing. That's the same thing, except they put the number on the wrong side. So you got to subtract minus 12. And we've got a leading coefficient of 2. So factoring is a pain in the butt. But it becomes bigger than 0 when we do it. But it's still the same thing. This is going to be the more challenging one. So right here. Oh, it didn't even copy it for me. How painful. Okay, here we go. We got to get the minus 12 to the one side, so I'm going to subtract 12. When I subtract 12 from the right side, it becomes 0. When I subtract 12 on the left side, it becomes minus 12. So essentially, this is saying, when is the graph above the x-axis? Well, we have to factor what multiplies minus 12 and adds up to minus 7. We would be dealing with minus 4. No. Plus 3 would be minus 6 and plus 1. No. Are we going to have to quadratic this? Am I just not seeing it? We need a positive and negative number to multiply it to minus 12. So minus 12 plus 1 doesn't work. Minus 6 plus 2 doesn't work. Minus 4 plus 3 doesn't work. So they're going to ask us to quadratically solve this. Am I missing something? I am not. Plus 12 makes a lot more sense because then it's minus 3 minus 4. Was it actually plus 12 and I misread it? No, it's minus 12. So that might just be a typo because now he's making us do the quadratic. If you don't like the quadratic function, this is an easy way. So if I factor out this 2, I'm left with x squared minus 7 over 2x. Forget about this number over here. And to find the vertex, I just have to half the number. Whenever you want to half a fraction, just double the denominator. And that tells me right away that that is the x value of the vertex. And I just have to plug it in to find the y value of the vertex. So I could do it that way. Just doesn't make sense though. Oh, wait, yeah. So stick with me. So I need to find the y value. So we're going to take our calculator and we're going to plug it in the positive 7 over 4 in wherever we see x. And let's just save in our memory. So we got to square it times it 2. I'm going to multiply it by 7. 7 times whatever it is. And we got to subtract 12. I don't think your teacher did this intentionally. So we get minus 18.25 is the y value. So I'm just going to put that here. Why aren't you copying? I don't know. There we go. So if I want to just make things cleaner, I'm going to use this minus 7 down here, like this. Do I have a 4? No, I don't. So I'm going to use this 4, like that. Make it a bit cleaner, cleaner, cleaner. There we go, minus 7 over 4. It's not squared like in here. It's squared on the outside. So I'm going to steal this 2 and put it square. And I'm going to put it there too. There we go. So now I have the completed square. And if I want to figure out the factors without using the quadratic equation, I just set this equal to 0. I add 18 to both sides. I divide it by 2. So it's 18.25 divided by 2. Now positive, by the way. Divided by 2, it's this. So when is this here equal to this here? We'd have to square root it first to get rid of this, right? When you square root it, you get positive and a negative result, always. So we get this. This is why I don't think he meant to do this. This is one answer. We'll just do it to there. And the other answer is negative. So we got this as a possible answer. And this is a possible second answer. And we just got to add 7.4 to both of them. So 7 over 4. I'm going to take this and add. Actually, let's not add. Let's clear my memory and save it in memory. There we go. Now we're going to add the 7 divided by 4. And we get that. So that's one possible answer for x. It's this. And then we're going to take the minus 3. And we're going to add 7 over 4. And we get this as the other. These are our two x-intercepts without using the quadratic formula. Let me use just this part of it. So those are two x-intercepts. So if I'm going to draw this on a quadratic, 4.76 is here, negative 1.26 here. This is an upward facing parabola. Looks like that. When is it above 0? When it's to the right of this line and when it's to the left of that. So when it's smaller than this and when it's bigger than that. I might have made some arithmetic errors, but that's the general idea. And if you're going to write it in notation, the left one, which is the negative, we would write as rounded bracket because you don't include infinity. Negative infinity to minus 1.26. Rounded bracket because it didn't say bigger or equal to 0. It just said bigger than 0. And rounded bracket 4.76 all the way to infinity. Positive infinity. Rounded bracket. Infinity is never included. That's why I don't think your teacher meant to do this. I think it was supposed to be minus 12 over here, become plus 12, and become factorable, which would be minus 3 minus 4. So just to put this into perspective, 2x squared, 2x squared plus 7x minus 12. Did we get the correct? I might have gotten, yeah, I got the opposite. Sorry. I somewhere I did a negative. Doesn't matter. I got the right ones just flipped. And so it's to the right of this point, to the left of this point. So when is this bigger than 0? It'll tell me like that. To the left of that point, to the right of that point. I got these reversed. That should be positive. That should be negative. Doesn't matter. I don't think your teacher meant to give you that. It doesn't make sense why he would do it. Just wants you to use the quadratic, I guess. If you want to use the quadratic, you find the 2 points, and you understand that it's upward facing, so it's to the left of the leftmost point and to the right of the rightmost point. This is more interesting. It's when is this quadratic above that quadratic? This is also a more common question. So if I have a simple quadratic, like that, let's make it downward facing. Like that, goes through these two basic points. And I have this other quadratic. There we go. I would ask myself, when is the purple line above the green line? Oh, this is a bad example because those are a pain in the ass. And graphically, it's quite clear. Well, the purple line is above the green line to the left of this point, but after the right of this point, it goes underneath the green line. But then it crosses the green line again, and then once again, it's above the green line. This is true of most parabolas. They'll meet in 2 spots, 1 spot, or no spot. So for instance, I could have this one like this, and the purple parabola is forever above the green parabola, but never below it. So this would be a weird one. But usually he's going to have it meet in a factorable way. So here's how you solve it. When is this graph above this graph? Well, as you remember from factoring, it's always easier to factor when we're equal to 0. Always equal to factor when we're equal to 0. So we really want to get a 0 on one side. So let's get all the x squareds to one side. I'm going to subtract this x squared from the right side. It's going to disappear because x squared minus x squared on the right side is 0. But over here, it's going to become 2x squared minus x squared, which just becomes 1x squared. Then I'm going to have the plus 12x, and I'm going to subtract 2x from the right side, and it'll just disappear. And then over here, it's going to be 12 minus 2x. Well, 12x minus 2x is 10x. So it's simply going to be 10x here. And then finally, we got minus 11 minus 13. When I subtract 13 from this right side, it becomes 0. And minus 11 minus 13 becomes minus 24. On the right side, suddenly, we have a 0. Now we can factor, because so if this said equals to 0, we would know, well, it's going to be equal to 0 at the x-intercept. So now we know to factor, but it says bigger than 0, but we're still going to factor. What number multiplies by minus 24, but adds up to 20? So the positive number is going to be bigger. It's going to be x plus 12 and x minus 2. Right, that adds up to positive 10, x minus 2, 12 minus 2, and multiplies out to minus 24, 12 times minus 2. So that tells me that for this thing that we've just done, I have a graph that would look like this. So here's the Cartesian graph. We would have an x-intercept that's opposite than positive 12, so minus 12. And opposite the minus 2, so positive 2. And it tells me this is upward facing. So we're talking about a graph like this. So when is this graph above the x-axis? Well, it's from this point way to the left forever. And from this point way to the right forever. So that's called negative infinity to minus 12. And this is called positive, or positive 2, comma, to positive infinity. And you'd have the curly brackets, I believe, to say that they're not included. Square brackets, solid square brackets, say they are included. To prove this is true, that this one graph that we started with is indeed above the other graph to the left of this point, minus 12, and to the right of this point, 2, we would go back to the original equations and just punch in the two equations separately. I'm going to punch them in separately. We've got 2x squared plus 12x. That's the leftmost equation. No. 2x squared plus 12x minus 11. So that's the equation on the right. On the left, on the right, we have x squared plus 2x plus 13. So the question here on the left is, when is this graph above this graph? And I'm saying it's when x is to the left of, what did we draw? X to the left of negative 12, and when we're to the right of 2. So let's have a look at the graph. So we can see the two graphs, and I can see it crosses here. Look at that at 2. So when is the top graph? Because that's the leftmost graph, right? The top graph. When is the top graph above? So when is purple above? Let's say red instead of black. When is purple above red? Well, I can see that purple is above red. You might be tempted to say, okay, purple's above red here, but it's not. So let's look on the left. Purple is below red on the left. It's quite clear until there. And it crosses over. And at that point on, for the left, to the left of wherever they cross, forever, purple is positive. So purple is above the red line to the left of wherever they cross forever. And we can see they cross at minus 12. So to the left of the x value of minus 12. The y values don't matter. When we're reading a Cartesian graph, we're finding the x value. So to the left of x minus 12. And you might be tempted to say, well, no, purple's clearly above red here until we look here. So no, red's above purple here, red's above purple here, red's above purple here, red's above purple. And that means when it crosses, it's no longer, it's below purple. And the reason we say this is because for this value, 3.26, look at the y value. It's 30.14. But when we go to the same value in the purple graph, 3.16, wherever we can find it, we can see the y value is much higher, which means since the y value is higher, the graph is higher. So purple is higher than red from this point forever on to the right. It's easier to see when you follow the line to a spot that you know is true. It's very obvious that the red line is above the purple line here. So whenever they cross, the reverse will be true. So essentially you factor to figure out where they cross and the truth of whatever is in the equation. Obviously those equations are going to get harder and harder. This one's just saying when is this parabola above 0? Well, you got the vertex minus 1, positive 4, and it's facing downwards. So you just got to figure out where it crosses the x-axis. And to do that, we know we have the y value here. We just would have to solve. So you subtract 4, you get minus 4. Take the square root. No, divide by minus 1, so you get positive 4. Take the square root, you get positive 2 or minus 2. Then you subtract 2. So you're talking about minus, the x-intercepts are 1 and minus 3, I think. Oh, is that the last question? Okay, well, let's solve it. To figure out when this is bigger than or equal to the x-axis, we have to know where it crosses the x-axis. It crosses, this is in vertex format, but it's actually quite easy to figure where it crosses the x-axis. Let's make it just equals to 0 and solve. Subtract 4. Divide by minus 1. Square root. When you square root, there's two possible answers. 2 and minus 2. That's the two possible square roots of 4. So when we square rooted, we got rid of this. So when does this equal this? And when does this equal that? Okay, subtract 1 in both cases. The answer for this one is 1. Subtract 1 here, minus 3. So those are the x-intercepts. So now we can draw it. At minus 2 comma 0 is 1 x-intercept. And 1 and minus 3. At minus 3 is 1 x-intercept. And 1 is the other. Since this was a upward, is it an upward facing? No, it's downward facing. And we know the vertex is at minus 1 comma 4 up here. We can now draw this like this. And then we got to go back and consult the question, ask what you want to know. I didn't quite get that right. Doesn't really matter. There you go. Good enough. What do you want to know? Well, they want to know when are we below the x-axis or equal. I can see it's to the left of minus 3 when x is smaller than minus or equals to minus 3 because they've asked us when it's below or equal to the x-axis. So minus 3 is right on the x-axis, so we have to include the equals, or when x is bigger or equal to 1. It's below the x-axis. So with vertex, it was actually quite easy to figure out the x-intercepts in this case because it wasn't decimals. We would write this in notation. To the left is negative infinity all the way to our minus 3. Or we would say or because there's two possibilities from 1 comma all the way to positive infinity on the right of the graph. Those are the two possible answers.